Three different liquids A, B, and C have initial temperature 15 degrees C, 25 degrees C, and 35 degrees C respectively. When A and B are mixed, they achieve 21 degrees C at thermal equilibrium. When B and C are mixed, they achieve 32 degrees C at thermal equilibrium. Find the temperature at thermal equilibrium for the mixture of A and C. Before we start our calculations, we will assign the symbols for the quantity that we have and collect the information that we have based on the questions given. The masses of the liquid ABC is indicated by MA, MB, and MC respectively. Their specific heat capacity CA, CB, and CC respectively. And then the initial temperature of TA, 15 degrees C, is TA equal to 15. We use a symbol capital T for temperature, and TB equal to 25 degrees C is for the temperature of the liquid B, and TC equal to 35 degrees C is the initial temperature of the liquid C. Now, if A, B are mixed, their temperature at thermal equilibrium is TAB equal to 21 according to the questions, and for the TBC is the temperature of the a mixture of liquid B and C at thermal equilibrium, which is 32, also given in the questions. So now the question asks us to find the TAC. TAC is the temperature of thermal equilibrium if we mix the liquid A and the liquid C. So what is the value for TAC? Our aims is to find this value of the TAC. When liquid A and B are mixed, they will exchange the heat. If you look at their temperature, initial temperature of AB, and compare with the temperature at the thermal equilibrium, okay, we can see that the TA initial temperature of TA is for the A is 15, initial temperature of B is 25, but the temperature at the thermal equilibrium is 21. So that means we can know that this liquid A will absorb the heat, and then liquid B will lose the heat because the initial temperature is 25, and the mixture, the temperature of the mixture at thermal equilibrium is 21, which is 25 is higher than 21. So that means this liquid B will lose the heat. So by using the Q equal to MC delta T, that formula, we can write down these equations. For the A, MACA, we use a higher temperature minus a lower temperature. And for MBCB, also higher temperature minus lower temperature. Because we only, when we this equation actually express that the heat absorbed by this liquid A is the same as the total amount of the heat lost by the object B. So we are considering magnitude only. Therefore, we always use higher temperature minus lower temperature for the delta T. Same thing happened for this second case, where when we mix the liquid B and the liquid C, in this case, the temperature at the thermal equilibrium is 32. So 32 is higher than the initial temperature of the liquid B, which is 25. Here is 25. So we use the 32 minus 25. So that means when the B mixed with C, B will absorb the heat, and C will lose the heat. Where, because how do we know? Because you check the temperature, we can see that the initial temperature of C is 35, this one 35, and then the temperature at thermal equilibrium is TBC is 32. Therefore, initial temperature higher than the final temperature. That means this object C lose the heat. So we use 35 minus 32. Again, both side balance. That means the total amount of heat absorbed by this B is the same as the total amount of heat loss by the object C. Okay, so now for the AC that we want to find, and we mix them, this A and C. You see the T, we want to find what is the TAC. Okay, but if you look at this initial temperature of this liquid A and liquid C, we know that initial temperature of A is 15. Initial temperature of C is 35, which is higher than 15. So that means we know that if we mix these two liquids, then this C will transfer the heat to the liquid A. So that means the temperature at the thermal equilibrium for the A and C must be lie between 15 and 35. Okay, since this is between 15 and 35, that means it's higher than 15, so we use TAC minus 15. So these terms at the left hand side shows that this object A will gain the heat, and the is a liquid A will gain the heat, and the liquid C will lose the heat. So we use 35 minus the TAC. Okay, so now we can, based on these comparisons of this temperature, initial and final temperature, we can know which liquid absorb heat, which liquid will lose the heat, and based on that, and we can apply the formula of Q equal to mc delta T to write down these three equations for the three different ways of the mixtures of the liquid. Now we can substitute the value for the temperature given in the equations into the three equations that we obtained just now. Then we have these three form of the equations. But the more important is that we want to see what is the relationship between these three equations. Our aim is to find what is the TAC in the equation number 3. But to find the value of the TAC, we need to know what is the MACA and what is the MCCC. These informations of the MACA and MCCC is not given in the questions. So how to solve? Okay, we need to know what is the relationship between them. To know the relationship between the MACA and MCCC, we can use this equation 1 and equation 2 to find their relationship. You look at this. We look at these two equations. You see, for the first equations, there's a relationship between MACA and MBCB. And equation number 2 is between MBCB and MCCC. So that means these two equations is connected through the MBCB. Okay, so connected through MBCB, that means from there we can find what is the relationship between MACA and MACA. Okay, MACA and MCCC. So using this relationship that we can find from equation 1 and 2, we substitute into the equation number 3, then we will be able to find out what is the value of the TAC. We start by simplifying the equation 1 and equation 2. Equation 1, 21 minus 15 is 6, so we have 6 MACA, and this 25 minus 21 is 4, so we have 4 MBCB, and I label this as equation 1A. And for equation 2, if we simplify it, 32 minus 25, we got 7 MBCB, and this 35 minus 32, it is 3 MCCC. So again, I label this as the equations 2A. To find the relationship between the MACA and the MCCC from this equation 1A and 2A, we now multiply the 1A and 1B. Multiply 1A and the 1B. Left hand side multiply with left hand side, right hand side multiply with right hand side. Then we have 6 times 7 is 42, and MACA and MBCB. and 4 times 3 is 12, MBCB and MCCC. So now we can cancel out this MBCB at the right with the MBCB at the left hand side of equality sign. So it will, and then this 12 and 42, we can divide them by 6. So 12 divided by 6 is 2, 42 divided by 6 is 7. So that's why we have 7 MACA equal to 2 MCCC. And if I now if I make this MACA as a subject of the equality of the equations, then I will have MACA equal to 2 or 7 MCCC. And I label this equation as the equations number 4. Equation number 4 shows the relationship between MACA and MCCC. Now we can use this relationship between them to find the value of the TAC from the equation 3. So what we do is that we substitute equation number 4 into equation number 3. If we substitute it, then this MACA will becomes 2 over 7 MCCC. And this MCCC will cancel out with the MCCC at the right hand side of the equality sign. So we will have this 2 over 7 times TAC minus 15 equal to 35 minus TAC. Now we multiply these equations with 7 at both sides. So the left hand side will becomes 2TA minus 30, and the right hand side will becomes 245 minus 7TA. Why 245? Because we take 7 multiply with 35. So now these 2 TAC and negative 7 TAC we can group together by bringing this negative TAC to the left hand side of the equality sign. Then we add up with 2AC. That's why we have 9 TAC at the left. And this negative 30 we bring it to the right hand side of the equality sign. So we have positive 30. Positive 30 plus 245. Then we have 275. So the TAC is equal to 275 divided by 9, 30.55 degrees C. So which is approximately 30.6 degrees C. Now this is the temperature that we want to find. It is the final temperature of the mixture of liquid A and the C. Or also it is the temperature at the thermal equilibrium of the mixture of liquid A and the C.